Hello everyone. So in the previous videos, we have completed these two questions, and now we are going to see what is the protection equipment used for the transformers. Okay. So if you see from a substation point of view, so in a substation, basically transformer is the most costliest part that are located in transformer in a substation, we can say. And from entire power system point of view, if you see uh, two equipments are very costly. There will be an alternators, and then second will be your transformers. Okay, so the air protections must be proper for a transformer. So what are the protections like we use basically? See, in case of transformers, there can be various things that we have to avoid. See, transformers, if I explain from the substation point of view, in substations, let's say this is your transformers. Okay, so first of all, we have to restrict, or we have to restrict the charges, the lightning that comes from the discharge of the cloud and all. So to protect the transformer from the lightnings and all, we basically connect the lightning arresters near the transformer on both the sides. Okay, so this lightning arresters, the characteristics of the lightning arresters are basically linear, non-linear. So basically at normal voltage, this lightning arresters offer us a kind of a finite resistance and all, but at heavy high voltage, because this lightnings will contain heavy voltage, you can say. So at heavy voltage, the characteristics of lightning arresters will be non-linear. So maybe up to some normal value it will be linear. So it can be linear. So let's say this is your voltage and this is your current. So up to some voltage level this will be linear. After that, non-linearity will start. Okay, this is your non-linear. So at very high voltage, what we'll do, you can see that very high voltage, somewhere here you will be getting some current. Okay, and ratio R is equals to VYI, right? So this is kind of resistance. So at very high voltage, this current will also be tremendously high, you can say. So this is the current. So at very high voltage, this lightning arrestor, it provides least resistance, because slope of the VI curve is basically represent the current resistance, and here the slopes are very less, you can say. So slope will represent the resistance or impedance, in whatever you want to say. So at very high voltage, it offers less impedance or less resistance, and it will absorb the entire power to it. Okay, and this is how basically it will work. By using lightning arresters, we can protect your transformer from the lightnings. What are the things? Other things. This is it. In transformers, we in for the internal protection point of view, in transformers, like it deals with the high voltages and all. And in transformers, inside there will be core and the copper materials, the conductors that will basically carry the currents and powers and all. Okay, so there is a chance that there can be formation of arc inside the transformer, and there, due to various or due to repetitive formation of the arc, there can be there can be you can say breakdown of the dielectric medium or the oils that we use in transformers. So basically, for the protection of the transformer from the internal fault point of view, because inside the transformer also there can be a various type of fault that we call it the internal fault, and to protect the transformer from the internal fault, we basically use Buchholz relay. Okay, so we use Buchholz relay. So this is our lightning arrestor. Then we have the Buchholz relay. Okay, we use inside the transformer to detect the internal behavior or internal abnormality of the transformers. Okay, and third, we use basically differential relays or differential protection scheme we use to protect the transformer from the internal faults. Let's say you have a uh, let's say this is your transformer coils and you want to protect it. Okay, so basically we use differential protection. So this is the windings that you want to protect from any internal fault. So we use differential protection. So it has two city connected with it, and it observed the incoming current and the outgoing current. If there is any variation of the incoming and outgoing current, then what will happen? Let me draw it. So basically, I'm drawing the simple differential relay, and here will be an operating coils. So let's say at normal condition, this incoming current and outgoing current are same. So the current that will go through this operating coil will be simply 0 ampere. But if there is a fault inside the, you can say the transformer coil windings and all, the incoming current and the outgoing current will not be same, and in that case the current that will go through this operating coil will not be zero, it will have some finite value. And if this current is more than the rate more than the, you can say the pre-specified values, then this particular relay, the differential relay will operate, and it will trip the it will send the trip signal to circuit breaker, and it will you can say it will trip. Okay, so it will detect the internal faults, and so by using the differential protection scheme or differential relays, we use this differential relay. There is some other types, like we have percentage differential relay or bias differential relay, but the bottom line is same, like to protect the transformer windings and all. Okay, and also there can be another scenarios, like in case of transformer, we also use harmonic restraint relay, that I will explain in some other video. But there is something we call harmonic restraint relay. Harmonic restraint relay, restraint, so the name is itself is suggesting, right? It will provide some resistance, you can say. So in case of transformer, if you turn on your transformer or switch on a transformer at no load condition, then the transformer, basically because of the saturation of the core, transformer draws a huge current that we call inrush current, that is almost 5 to 6 times of the full load current. But it is not a dangerous things that basically it is not a, you can say it comes and it exists for a minute duration, and it is not a like dangerous scenario, or it is not a very critical thing. But it also, like that high magnitude of current can be a trigger point for the overcurrent relays. Like it can be trigger point for this particular differential relay also. So to restrict our differential relay to operate against the you can say this high induced current, we use basically harmonic restraint relay. I will explain this particular concept in another video. But we also use harmonic restraint relay uh, to against the mal-operation of the transformer. Okay, now we have something we called restricted earth fault relay. In restricted earth fault relay, we basically restrict our protection scheme in a particular area. That's why we call it as an earth restricted earth fault relay. That is also used for the protection of the transformer winding. So the fifth is called a restricted earth fault relay. Restricted earth fault relay. So it is used for the, you can say the against the earth fault that can occur in the transformer winding. This particular relay is also used in a alternator or in a synchronous motor to protect against the earth fault relay and all. So what happens? Let's say you have the three phase of the star windings. Let's say this is a three phase. Okay, and this is your ABC phase. Okay, and you have the fault at the windings, and now you want to detect how this why this fault has occurred, and I have to send the trip signal and all. So for that particular case, we use the restricted earth fault relay. And earth means like in a fault, if your earth is associated, then it is, we call it as earth fault. Okay, so the, if you see the circuit diagram and all, we'll be having a CT connected at the neutral. This is neutral, and this neutral is grounded basically, and also we have CTs here. So let's say, okay, sorry, yeah. So let's say this is your A phase, B phase, C phase, and basically you will be having this to connect it together, and here will be your operating coils. Okay, this is your operating coil. Okay, and this restricted earth fault relay, operation of this restricted earth fault relay will be restricted to this particular zone. Like if any fault occurred in this area, then only this particular relay will operate, or else it will not operate. Like if the fault occurred here, somewhere here, then this particular relay will not be will not be able to detect the fault and all. I'll explain the operation and all in the another videos, but these are the like you can say the main scenarios, main protection that we basically we use in transformer. I'll explain like operations and all, how it can detect fault only in this particular area and all. I'll explain. But in this particular video, my intention was to just give an idea like what are the different protection scheme we use in case of transformers. If you have any doubt, you can ask me in the chat box. Thank you.